Hi, I'm Bob Warfield from CNC Cookbook, and today I want to talk about toolpaths and getting the most from your CAM software. If you're like most CNCers, and like I used to be, you probably let your CAM software use as many defaults as possible when you're laying out a toolpath. After all, it takes time to change them, and often it's not clear whether it would help. But I'm here to tell you, it's worth looking into some of those defaults. The reason is that the defaults really do matter. I'm going to go over some of those details for you and show you how you can improve your tool life and surface finish with some tips for entry to cuts and climb versus conventional milling. Remember, you can do better than the defaults. Let's start with entry to the cut when 2D machining. Perhaps you're using a face mill to surface the top of a workpiece, or perhaps you need to bring the cutter into the material to cut the outer walls of a part. Your best strategy is to arc in as the graphic shows. This keeps the chips thin on entry and is much gentler on the cutter. A gentler entry is helpful in tough materials such as stainless and others. It helps prevent chipping the cutting edge and can considerably improve your tool life. Here's another approach you can take. Oh, sorry for that pun. It's called a tangential entry. The idea is to bring the tool in on a corner, as I've shown here, where you can enter tangentially to the cut. When you think about tangential cutting, think about it in the same terms as a high-speed machining toolpath. Coming in on a tangent helps to avoid corners and allows you to increase your cutting speeds. By entering tangentially, that's exactly what's happening here too. You're going to avoid the sudden increase in cutting forces that a corner can bring. And that's why this approach is much better for your cutters. Let's talk about entering pockets. There's really 4 ways to deal with that. And the other 2 methods are not going to help you because you have to descend vertically into a pocket to begin the cut. So, the first method, which I'm showing here, is to plunge your cutter straight down. It's the least preferable method because it's slow and it's hard on your cutter. Chip clearing is toughest with this method, as the only way the chips can escape is via the cutter helix. That means they're in contact with and wearing your cutter for the maximum length of time. Being down in the hole like that, it also means it's hard for coolant and air to reach the cutter and keep it cool and well lubricated. None of that helps, but on top of it all, you must also use a center cutting tool to even be able to perform a plunge. Personally, I try never to plunge unless there simply is no room to do anything else. The next most desirable method is a ramp entry. It's much better than plunging. You can run a faster feed rate because you've got better chip clearing. But if you think about it, the chip clearing isn't a lot better, it's a little better. Running a ramp like that is just like cutting a slot, full slot. Experienced machinists know slots are harder on their cutters. Now I know some of you smart guys out there are thinking, what about trochoidal slotting? Clever idea, and that's basically what our next method is all about. Getting your cutter moving in a circle is almost always a good idea. That's what happens in trochoidal slotting too, but it's also what happens with a helical entry to a pocket. A helix can be faster than a ramp because the chip clearing is excellent. It's analogous to pocketing after all, which is faster and easier than slotting. You want to try to keep a large enough diameter helix that it's easy to clear the chips, and be sure to aim your coolant nozzles so they're coming in at an angle to blast the chips out of the hole and drive them out. Here's what's possibly the best form of entry to a pocket that you could ever use, and that is to have a pre-existing hole. If there's already a hole there, the end mill can just fly down and start cutting right away to make it larger for your pocket. The trick is you'll need a large diameter, potentially an indexable drill. Such tools have typically higher removal rates than end mills helixing. The trick is going to be whether your savings from the higher material removal rate will offset the cost of the additional tool change. One way to save is to stack multiple parts on a fixture so you only have to pay for that tool change once for all the parts. That helps a lot. It's always worth considering a pre-existing hole if you have it available to you. Okay, now let's turn our attention away from entering the cut. All machinists are familiar with climb versus conventional milling, right? And most CNCers just always climb mill. After all, it reduces your cutting forces, which leads to less tool deflection, and that often gives longer tool life and better surface finish. Except when it doesn't. Here's a surprise. It's often advantageous to go conventional instead of climb milling. Don't just blindly specify a climb cut every time. Here's the thing. In effect, that's basically like the reverse of chip thinning. When you climb cut with a cut width or step over that's more than 3/4 of the cutter's diameter, it actually changes the cutter's geometry so it's more negative rake. I think the folks at Dapper discovered this way back in 1971, but not too many CNCers know about it. That negative rake raises your cutting forces and means the cutter is not working with the geometry it was designed for. If you switch to conventional milling, it restores the expected geometry and the cutter works as it should. Here's another weird thing you can see from the diagram here. The direction of tool deflection is more likely to be into the wall of the cut when you're climb cutting, whereas conventional milling, the deflection is usually in the direction of the path the cutter is following. That means that if there's sufficient deflection, the climb mill will suck the tool into the wall, increasing your chip load, and that's lousy for your tool life, surface finish, and the accuracy of the cut. But here's the thing, the cutting forces are less on climb milling, so it's less likely to deflect. How do you know whether to use climb or conventional? Here's the deal. Use conventional if your cut width is over 3/4 of the tool's diameter. It's just a good idea to preserve proper cutting geometry. In all other cases, run climb milling and check on tool life and the surface finish of the wall. If it isn't what you want, it may be due to deflection issues, and you'll need to try a conventional milling run to see if things improve. There's really no other way but to test, and you'll be surprised at how often conventional milling improves the situation. Hey, thanks for listening, folks. I'll be back soon with another installment of the CNC Chef.